In this presentation, I am attempting to help you understand what is meant by a pragmatic truth. In class, we have considered the coherence test for truth. We looked at this in relation to memory being coherent with artifacts. We looked at interpretation of the arts in relation to what other people might interpret an image to look like. So a pragmatic truth is a truth which gives you predictive power and explanatory power, but it may not correspond to reality. So in science, a knowledge issue is to what extent can inductive reasoning lead us to the truth? Recall that a knowledge issue is an equivocal question, one where different people would have different answers, and an inductive reasoning is making individual observations into a generalization. So this is a real-world example, meaning that this is something that a student could make a presentation on in theory of knowledge. The example I'm going to go into is related to Ignaz Semmelweis and the case of childbed fever. And the word child should not be capitalized, by the way. Semmelweis was a manager, I guess you could say, of a hospital in Vienna. This is going back to the time when Austria and Hungary were part of the same empire, the Austro-Hungarian Empire, and Semmelweis was a Hungarian. That's a picture of the hospital. It's quite big. You'll notice that the hospital is divided into 4 wings. So that's the date range he was alive. It gives you a sense of the time frame. That's his picture. Looks very characteristically Hungarian. What this graph shows you is childbed fever or puerperal fever and the graph of the yearly mortality rates. The first clinic had much higher rates of death in mums who came to the hospital to deliver their babies compared to the second clinic, which had much lower rates. So this, of course, the difference in the rates caused people to think, well, there must be some explanation. And one of the hypotheses was it was a positive feedback cycle, which you might have learned about in biology. A death would lead to a priest and his acolyte walking through the ward, ringing a bell, which would scare other women, and they would die of fright. And that was a possible explanation. The issue was that the hospital was becoming notorious, and that there was a higher rate of death from childbed fever from people who never even came to the hospital, and people were thinking perhaps they should just avoid the hospital altogether. So this is an example of how scientific truth can be developed, and in science we can always be sure of what isn't the case. One possible explanation was that this was an epidemic, that the childbed fever was contagious, and if one woman was stricken by the epidemic, then her neighbor would get it. But that pattern, there's a pattern to epidemics. It's sort of often there's an epicenter associated with the first case, and it's circles of increasing radius where you see the subsequent cases. But that wasn't the pattern that was seen. Sometimes it would be neighbors, other times it would be one side of the hospital, and another side of the hospital would be the next patient. One concern, possibly it was women who were on the outside wall where it was a bit colder. Remember the timing of this, they didn't have central heating, they would have fireplaces. So fireplaces definitely heat a room unevenly. So the concern was perhaps it was women who were too far from the source of heat. But there was no difference in the mortality rates on the inside and the outside walls. So what you're seeing, in fact, is a process of falsification. They're increasingly becoming certain of what isn't the case. It's not an epidemic, it's not chilling, and it's not the death knell. So what was noted, though, was that there was a higher frequency of delivery by doctors in the second clinic compared to the first clinic where midwives delivered the babies. Midwives, being more empathic towards women, allowed the women to get up and walk around in the delivery and possibly even deliver standing up, whereas doctors were more likely to immobilize the mum and strap her legs up. So the doctors tried to more frequently deliver babies the way the midwives did, but it didn't decrease the rate. Doctors have much bigger hands, so there was a correlation study, childbirth death by childbed fever versus hand size of the doctor delivering it, and there was not a statistical correlation. Interesting application of math. Great math studies project. Then what was detected is that a doctor who was performing an autopsy poked himself during the autopsy and died from the conditions similar to the women who were dying from childbed fever. The conclusion there is perhaps it's the dead stuff on the doctor's hands. Noting the time in history this is, the doctors would go from conducting autopsies to delivering babies without washing their hands in between, because the whole notion, the germ theory of disease, is actually not known at this time. And lo and behold, what they did is they started to wash the dead stuff off. What the doctors shared in common in the second clinic was they all performed autopsies. So they were told, wash your hands to get the dead stuff off, and the red line indicates the rate of death from childbed fever after hand washing was introduced. And the conclusion was that childbed fever was caused by matter from dead people. It's a pragmatic truth, but it may not be right, because it's doctors who are not washing their hands because it has dead stuff on that's causing the childbed fever. It's sort of true. If I wash it off, it stops the childbed fever. So that means it's a truth which works. Doesn't mean it corresponds to reality, but it works. If cadaveric matter is causing the fever, then washing it off solely after autopsies should stop the fever. And it did. However, it's actually bacteria in the cadaveric matter. If they gardened and delivered a baby, they wouldn't be thinking they needed to wash their hands because there's no dead stuff. They could quite clearly transmit tetanus from gardening to the mum. So if they gardened and the mum got childbed fever, they might say, oh, there must have been dead stuff in the soil. And they wouldn't be right. An example from my own teaching career is when I first started teaching the IB, I remember teaching that there were 100,000 genes in the human genome. That was the best way to explain the diversity of phenotypes seen in humans. And if I had asked on a multiple choice question, I might have said, how many genes are in the human genome? 100,000, 50, 25, 10. And if you had circled 25,000, what people think to be the correct number, I might have marked you wrong. And so how can we explain diversity in human phenotypes? Well, My pragmatic truth was that there were a great number of genes. It explains things. It helps me predict diversity. The more genes, the more diversity. It predicts and it explains, but it's not right. But it's a pragmatic truth. Predicts, explains, but may not correspond to reality. Now the question is, if we can't be certain that anything we learn in science corresponds to reality, why do we bother learning it at all? Well, if you consider this example, what they were certain of was that it wasn't an epidemic, it wasn't caused by chilling, it wasn't caused by the death knell. So there are things that we are certain of, things we have ruled out by experimentation. Our current status of knowledge may prove to be limited in the future, but as long as it predicts and explains, then that's the nature of a scientific truth. Increasingly accurate because of ruling out what isn't the case, but possibly not the final truth. Provisional truths give us predictive power. Science can provide us with certainty of what's not the case, and each revised truth brings us closer to reality. Break.